Hello and welcome back. And in this lecture, we are going to discuss about the embedding encoding for the categorical variables. This is one of the encoding technique for the categorical variables when there are number of categories under a categorical feature. For example, if we are talking about the countries, right? So countries is it's a kind of categorical variable. It's a categorical feature, and in this we can have number of countries around 200, 300 countries list could be there, right? So based on the data or based on the context, the number of countries could be lower or higher in number, right? But yeah, the number of countries could be significant, right? So in that case, what will happen that you can get a very big matrix or very big number of sparse features or the new features or the new columns to be added into the data set. So if we will add those many columns into the data set, then in that case it will become really tough for the model to understand the relationship, right? And it will become complex as well, right? So before we understand the theoretical part of the embedding encoding, let me show you a simple example so that you should be able to understand that what we do in the embedding encoding, and then we will see the important points that you must need to remember about the embedding encoding. So we have taken here an example where you have to imagine that you have a simple vocabulary where there are only three words. One word is cat, the other one is dog, and the third one is bird. Okay. So if you do the one hot encoding for this categorical feature where we are just giving these three words, or you can say like you are giving a categorical feature with name animals, right? So these are the three categories for those animals: cat, dog, and bird. Now, if you do the one hot encoding, how many columns you need? You need three columns, because in one hot encoding, there are, since we are able to see there are three categories, so we will be creating a 3 cross 3 identity matrix, right? If we will creating the 3 cross 3 identity matrix, then it will be something like this. For cat, we can have 100, for dog, we could have 010, and for bird, we could have 001, right? So this is simply, having the different features, added features when we are looking into these categories. But whenever we have the data, right? Whenever we have the data for any of the purpose for creating a data model, then in that case, if the purpose of the data to have the data is to find out the relationship between the different categories as well, to find out some inference from the data based on these categories, then in that case, just traditional way to just create new features, new feature columns will not work here. So in that case, we will need to capture the semantic relationship between these words. Semantic relationship means, semantic means the underlying meaning, right? Suppose you are talking about like someone is sitting, uh, like someone is sitting on the desk, or someone is sitting lying on the bed, right? Someone is lying on the sofa, right? In that case, the literal words are something else, right? Like someone is sitting on the sofa, this is the literal meaning, right? Someone is sitting, but there is an underlying meaning that he is relaxing. Relaxing is the underlying meaning, that someone is relaxing. Someone is sitting on the sofa, right? And the other way to find out some way, find out some other meaning for this sentence is that someone is relaxing. That person is relaxing who is sitting on the sofa. So whatever we can take the inference from a literal sentence, that is known as the underlying relationship or the semantic relationship. I hope you are now getting the point, like what is the semantic relationship. So semantic relationship means the underlying meaning of the relationship, right, of the sentence, right? So these, if you do the one hot encoding, then in that case, these things are not going to give you any of the semantic meaning, any of the semantic relationship, right? So one hot encoding in that case is not useful. And also, if there are number of categories, then also one hot encoding is not really useful, right? So what we will do, we will do embedding encoding. In case of embedding encoding, what we do, we try to find out the semantic relationship between the two different categories, or the number of categories whatever are available. So based on the proximity between the two different categories, we create a lower dimensional vector. Like here it was a vector of 3 cross 3, or you can say a matrix of 3 cross 3, but here if you see, it's 2 cross it's 3 cross 2 only. One dimension has been removed. 3 cross 2 it has become. Here it was 3 cross 3. So why it has become 3 cross 2? Because we are just going to take a relationship between the different categories, right? For example, here if you see, we are defining a two-dimensional space. We can give any dimensional space for the output, right? This is our input, right? This is the input, like 3 cross 3 could be the dimension when we are doing the one hot encoding, for example. If we are doing binary encoding, then it could be something else, right? It will be around yeah, it will be there will be only two bits needed, so it will be 2 cross 2. But when we talk about the embedding encoding, then in that case it's up to us that what is the output um, dimension, right? We decide that what should be the output dimension. Whatever dimension we want, we have to give that. And on what basis we will be giving that? We will be giving that on the basis of like how we want our model to find out the proximity relationship. Like here, if you see cat and dog, they are very much similar, but the bird is very much away from these two similar, the similarity of the cat and dog, right? That's why you can see that cat has 0.2 and dog has 0.3, the first column, and cat has 0.7 and dog has 0.6. So in terms of similarity, right? In terms of similarity or the similar meaning, right? They both are, having four legs. They don't fly. Both of them don't fly. So there are lot many similarities between them, but still they are not exactly similar, same. So that's why we are not going to give exact, value like 0.3 or something like that. So this is a very complex calculation, and this complex calculation to find out the uh, you know, uh, a kind of output vector where we are giving a real number to the vectors, right, to the different row and columns in this matrix. That calculation is done based on the neural network systems. Neural networks is not the part of this particular course. I will be creating a separate course on the neural networks where you will be learning all these things. But here, just understand that neural network provides this kind of thing. Like there are different algorithms. Using those algorithms, we are able to calculate these, right? And those algorithms have been provided by the Python libraries, right? So based on that, we get these relationships, and based on the relationships, we get a lower dimensional space, lower dimensional vector space, or you can say a lower dimensional features, lower dimensional vectors. You can say better word is lower dimensional vector. So this is the way you can, with the help of embedding encoding, you can reduce the dimensionality, right? So basically, embedding encoding is useful where there are number of categories in your data under a categorical variable and or a categorical feature, and you have to understand, or maybe you don't have to understand the semantic relationship. Even then you can go with this one, right? So that you can have a semantic relationship angle as well, right? There is one more thing to understand, which is the semantic meaning between the variables or the values, right? So that could be useful. So if there are number of features, then you will be using it. So why this is useful? Embedding encoding allows model to understand semantic relationship between words. This is crucial for tasks like text classification, right? Whenever you are classifying the text based on its meaning, machine translation, translating text from one language to another, you can understand it's really useful that if you have to translate one text from one language to another, then you need to understand the proximity between the two words, right, of two different languages. Text generation, generating human quality text, right? So in the case of text generation as well, if you have to generate some new text or the new or the next word in a sentence, right? Suppose you write something, my name is, or good, you have written good, then it could be morning, it could be evening or anything, right? So in that case, based on the existing data, it can learn the pattern and can learn the neuro-linguistic programming for the text generation. By using embedding techniques, models can better understand the context of word and make more accurate predictions. So basically, when you have to do the predictions, then in that case, this kind of encoding for the categorical features you can do. So mostly these things are useful. This kind of embedding, I mean, this kind of encoding is useful for those cases where we are doing the text analytics, right? So I hope you must have understood the basic concept related to the embedding encoding, and there are few points here, like how it works. So this is all about very basic thing that I have told you. Like first we have to assign unique category. Unique category is assigned to unique integer. Every category you assign a unique integer. Then you create an embedding layer where the embedding calculations are performed, right? Embedding algorithms are performing the calculations, like what value I should assign in the vector, right? So after that, learn embedding, which is the neural network task, right? So here you decide the input dimension. Input dimension is the number of unique categories. That is, we are already aware of. Like here, if you see one hot encoding, so we are aware of, like this is the 3 cross 3. But yeah, if you go to the output layer, then you decide that yes, I want these many, this should be the dimension when I give the output. Okay. So that is the thing. I mean, you based on the data and based on the domain expertise, you can decide like what should be the output dimension. Okay, so with this, I would like to conclude this particular lecture, and in the next video, we'll see some piece of code that we will write to generate the generate this thing, like embedding encoding data. Okay, from the existing set of data. So we'll meet soon again. Till then, have a nice day and bye bye.